Hello dear friends, and welcome to the second part of Unity programming tutorials. In this session, we will focus on learning variables and printing messages in Unity. Let's get started with the lesson. We want to display a message in the Unity console. It's very simple. We write print. Put the message we want inside double quotes, close the statement with a semicolon, and save the code using Ctrl+S. Or we can use Visual Studio's Save option to save the code. We wait for the script to compile in the Unity environment. After the script has compiled, we still need to attach it to a game object in order to run it. To create an empty game object, simply right-click in the Hierarchy panel and select Create Empty. Then, we can easily drag and drop the script onto the game object in the inspector to attach it. Another way to attach the script is to click Add Component, search for the script in the search bar, and select it. After attaching the script, we run the game, and as you can see, the Hello World message is printed once. Now, the reason the message is printed only once is that we wrote the code inside the start function, and the start function runs only once at the beginning of the game. To make it run continuously, we just need to put the message printing code inside the update function, which runs every frame. Then, we save the code, wait for it to compile, and run the game again. As you can see, the message is now being printed continuously every frame. Another way to show messages in Unity is using Debug.Log. This is used more often because it's more flexible. With Debug.Log, you can not only show a normal message, but also display messages as warnings or errors. This makes it very useful for testing your game and keeping track of what's happening while it runs. It's the most common method professionals use to show messages in the Unity console. As you can see, just like print, Debug.Log also shows the same message in the Unity console. Now, to print messages as warnings or errors, we simply use Debug.Log warning to show a warning and Debug.Log error to show an error. After the script has compiled, we run the game, and as you can see, now one message is displayed as a warning and another as an error. Now let's talk about variables. Variables are basically containers that we use to store information in our game. Think of them like little boxes where we can keep different kinds of data. For example, we can store numbers, text, true or false values, and much more. We create variables so we can save information and use it later in our game, like a player's score, the speed of a character, or the name of an item. Every variable has three things: a type, which says what kind of data it can store; a name, so we can use and access it in our code; and an initial value, which is optional. We can give the variable a starting value right away, or we can leave it empty and set its value later in the code. Variables are one of the most important basics in programming, and you'll use them all the time when making games in Unity. The first variable type we're going to learn is byte. A byte is used for storing small whole numbers, and it can only hold values from 0 to 255. This makes it a very lightweight type. We use a byte when we know our numbers will always stay in this small range. For example, Unity uses bytes inside color32 for the red, green, blue, and alpha values, because each of those goes from 0 to 255. A byte can be created with or without an initial value. If you don't give it a value, it automatically starts at 0. The only thing to be careful about is that bytes cannot store numbers bigger than 255, and they also cannot store negative numbers. The next variable type is spite. It's very similar to byte, but the difference is that spite can store negative numbers, and spite can hold values from -128 to 127. So instead of only positive numbers like byte, this one covers a small range of both negative and positive values. Just like other variables, you can create it with or without an initial value. And if you don't set a value, it starts at 0. We don't use spite very often in Unity, but it's good to know it exists when you need a very small type that includes negative numbers. Now let's move on to the next variable type, which is short. A short is used for storing whole numbers, but it can hold a much bigger range compared to byte and spite. A short can store values from -32,768 to 32,767. So it supports both negative and positive numbers, but still uses less memory than an int. You can create a short with or without an initial value, and if you don't set anything, it starts at 0. In Unity, we usually use int more often, but short is useful when you want to save memory and your numbers don't need the full range of an int. Now let's look at ushort. This type is similar to short, but it cannot store negative numbers. A ushort can hold values from 0 to 65,535, so it gives you a larger positive range than short, but no negative values. Like other types, you can create it with or without an initial value, and if you don't set one, its default value is 0. We don't use ushort very often in Unity, but it's useful when you need a bigger positive range while still saving some memory compared to int. Now let's move on to int, which is one of the most important and most commonly used variable types in C#. An int is used for storing whole numbers, and it has a large range. It can store values from -2,147,483,648 to 2,147,483,647. Because of this big range, int is the standard choice for most numeric values in Unity. You can create an int with or without an initial value, and if you don't set anything, the default value is 0. In Unity, we use int all the time for things like health, score, ammo, counting objects, or anything that requires whole numbers. Now let's talk about uint. A uint is similar to int, but the difference is that it can't store negative numbers. A uint can hold values from 0 to 4,294,967,295, so it gives you a very large positive range, but no negative values at all. Like other types, you can create a uint with or without an initial value, and if you don't set one, the default value is 0. We don't use uint very often in Unity, because most of the time we need both positive and negative values, and int is enough. But if you're sure your values will always be positive and large, uint can be useful. Next, let's talk about long and ulong. Long is used for storing very big whole numbers, and it can store both positive and negative numbers. Ulong is similar, but it only stores positive numbers, giving you a bigger range for positive values. Just like other variables, you can create them with or without an initial value, and if you don't set one, the default is 0. You usually use long or ulong when your numbers are too big for int or uint, but in most Unity projects, int is enough for normal values. Now, let's move on to variables for storing decimal numbers. The first one is float. A float is used to store decimal numbers, numbers with fractions, like 3.14 or 7.5. It's lightweight and commonly used in Unity for things like position, speed, rotation, or scale. A float can store numbers with up to 6 digits after the decimal point, so it's good for most general calculations, but not super precise ones. When you write a float number in code, you must put the letter F at the end. This tells C# that the number is a float. For example, 3.141592F. Next, let's talk about double. A double is also used to store decimal numbers, but it's more precise than float. It can store numbers with up to 15 to 16 digits after the decimal point, so it's great for calculations where you need higher accuracy. When you write a double number in code, you can add the letter D at the end to make it clear it's a double, like 3.141592D. If you don't add it, C# still treats the number as a double by default. In Unity, we usually use double for very precise calculations, but for most gameplay numbers like position or speed, float is enough. Finally, let's talk about decimal. A decimal is used to store very precise decimal numbers, much more precise than float or double. It's usually used for money, financial calculations, or anything that needs exact values without rounding errors. When you write a decimal number in code, you must put the letter M at the end to tell C# that it's a decimal, like 3.14 M. Decimal is heavier than float and double, so it's not used for general gameplay numbers, but it's perfect when accuracy is critical. Now, let's talk about the bool type. A bool is used to store logical values, which means it can only be true or false. It's very useful for decisions and conditions in your game, like checking if a player is alive, if a door is open, or if a button is pressed. You can create a bool with or without an initial value. If you don't set it, the default is false. For example, a bool can be used to control whether an action should happen. Bool is one of the simplest but most important types in programming, especially when using if statements and conditions in Unity. Now, let's talk about character types, starting with char. A char is used to store a single character, like a letter, number, or symbol. When you write a char in code, you must put it inside single quotes. You can't put more than one character in a char. If you need multiple characters, you'll use a string instead. Chars are useful for things like checking a single key press, storing a letter, or handling text one character at a time. Now, let's talk about string. A string is used to store text, which can be multiple characters, like words, sentences, or even paragraphs. For example, hello world, player 1. When you write a string in code, you must put it inside double quotes. Strings are very common in Unity for things like UI text, player names, messages, and more. You can also combine strings, get their length, or access individual characters if needed. Alright, this lesson ends here. In this session, you learned about different types of variables, numeric, decimal, logical, and char and string, as well as how to display messages in Unity. If you enjoyed this lesson, we'd be really happy if you support us by subscribing to our channel. See you in the next session. Goodbye.